All right, so for part A here, it says what is the standard error of the slope of the regression line and interpret it in the context of the problem. So remember, standard error for our slope is equal to s over sx times the square root of n minus 1. Okay, so we have all that information. Sx is here, s is here. So we're going to do 7.288 divided by 88.57 times square root of n minus 1. So we're going to square root of 9. Okay, which gives us 0.0274. Okay, and remember SEB, this is the standard error for our slope of our regression line. Okay, and remember standard error is just when we're having to use S and SX instead of the population standard deviations and stuff like that, we change it from standard deviation to standard error. Okay, so this is the standard. Think of it like standard deviation of the slope. Okay, so remember the definition of standard deviation is basically how far everything varies from the mean. Okay, so the mean in this case would be the slope of our sample regression. Okay, so the interpretation is going to be something like, if we were to repeat this process many times. And what process are we talking about? We're talking about the situation where we're looking at, 10 Mega Millions drawings in history and recorded how the ticket sales were for that drawing. So if we repeat that process of randomly selecting 10 new drawings, then the slope of the sample regression equation would typically vary by 0.0274. And this is the slope, so that would be millions of dollars per millions of sales. Sorry. Okay, so that's our slope from sample regression equation to sample regression equation. So basically from one slope to the next slope, we're going to vary by this standard deviation.